the manufacturing definition. What is manufacturing? Converting a raw material into a finished product. So in order to convert into a raw material into a finished product, we required a lot of process. So not only a process, even it required a lot of tools also. So that things complete the convert that raw material into a finished product. Now what are the process we're going to carry out there? That is called manufacturing process. That is the next thing. What are then types of manufacturing process? As we discussed yesterday, there are different manufacturing process like forming, casting, molding, joining, machining. These are the old traditional technology. Now we are moving to the next technology called as additive technology. These are the various forms of manufacturing technology. And the example for forming like forging, extrusion rolling, and die casting, sand casting, investment casting. For molding, injection molding, compression molding. For joining, welding, soldering, fastening. For machining, turning, drilling, reaming, like additive 3D printing. So these things will take up in one video. We'll discuss in one video all these types of process of manufacturing with a beautiful 3D animation that I'm going to play it now. So please, you can just look into that. Adralle nimge idea banbidutte ella types. Are you ready?
Yes, sir.
You ever wonder how Do you ever wonder how amorphous lumps of material are turned into everyday products which surround us? Let's find out. In this video, we're going to talk about manufacturing processes. There are 6 main categories of manufacturing.
Sorry. One minute.
Do you ever wonder how amorphous lumps of Do you ever 6 main categories of manufacturing processes, which are forming, casting, molding, joining, machining, and additive manufacturing. Each one of these categories contains a large number of different manufacturing techniques. There are a lot of different factors which need to be considered when selecting the right manufacturing process. This includes the material you are working with, the geometry of the object, the number of parts you are producing, tool and material costs, and required levels of automation. Do you ever wonder how amorphous lumps...
See, the thing is, first what he's saying, what are the different types of manufacturing process he said. Then in order to select what are the types, which one we need to select is based on the selection process, it based on the different types of factors. Like it may be like what are the factors he's saying. One is what type of material we are going to manufacture. Based on that, we need to select the what type of manufacturing process. Second thing is what type of geometry we need to produce, whether it is simple in geometry, complex in geometry, then we need to select the corresponding manufacturing process. The next thing is factor we need to be considered is number of parts, whether it is go for small production, whether it go for mass production, then we prefer the different types of manufacturing corresponding we need to select. Then tool and material cost. So what may be the based on the tool we need to manufacture that, based on that we need to select the right type of manufacturing process. Then required level of automations. So what kind of automation, whether it is manual type of manufacturing, if it machining is required, or it is completely like a complete automation, then we need to select the right different types of manufacturing process corresponding to that. So these are the process selection dependent. So now we're going to take up what is one by one, what is forming. So here forming basically involves by applying a pressure or a force, we are going to get the required shape of the material. When you apply the force on the material, what will happen? Definitely the material going to be deformed, right? Yes or no? So based on that deformation, what will happen? It get the required shape according to that. So that is the things what he's saying here. That is called forming process. So in the farming process, basically this farming process, we are going to manufacture using metal material made up of the material, the product is made up of metal. So basically here we are going to follow with the two working process. One is hot working process and another one is the cold working process. Basically what is idu on the intro questions irutte. What is hot working, cold working, enu difference andre? Hot working andre we are going to heat the material above the recrystallization temperature, then we do a farming process. Cold working andre we are going to heat up the material below the recrystallization temperature. So what is recrystallization temperature andre? So when you heat the particular temperature, ಯಾವುದೇ ಮೆಟೀರಿಯಲ್ ಹೀಟ್ ಮಾಡಿದಾಗ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಟೆಂಪರೇಚರ್ ಆದ್ಮೇಲೆ ಏನಾಗುತ್ತೆ, ಅದ್ರದ್ದು ಪ್ರಾಪರ್ಟಿ ಚೇಂಜ್ ಆಗುತ್ತೆ. ಯಾಕೆ ಪ್ರಾಪರ್ಟಿ ಚೇಂಜ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ ಒಳಗಡೆ ಅದ್ರದ್ದು ಇರೋ ಮೈಕ್ರೋ ಏನು ಸ್ಟ್ರಕ್ಚರ್ ಇರುತ್ತಲ್ಲ ಅದು ಚೇಂಜಸ್ ಆಗುತ್ತೆ. ಆ ಚೇಂಜಸ್ ಆದಾಗ ಏನಾಗುತ್ತೆ, ಅದು ಪ್ರಾಪರ್ಟಿ ಚೇಂಜ್ ಆಗುತ್ತೆ. ಸೊ ದಟ್ at particular temperature which recrystallization the microstructure is going to be changes, ಅದನ್ನ ರೀಕ್ರಿಸ್ಟಲೇಷನ್ ಟೆಂಪರೇಚರ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಅದಕ್ಕಿಂತ ಕೆಳಗಡೆ ನಾವು ಏನಾದ್ರೂ ಹೀಟ್ ಮಾಡಿದ್ರೆ ಅದನ್ನ ಹೀಟ್ ಮಾಡಿ ನಾವು ವರ್ಕ್ ಮಾಡಿದ್ರೆ ಮ್ಯಾನುಫ್ಯಾಕ್ಚರಿಂಗ್ ಪ್ರೊಸೆಸ್ ಮಾಡಿದ್ರೆ ದಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಕೋಲ್ಡ್ ವರ್ಕಿಂಗ್. ಅಬೋವ್ ದ ರೀಕ್ರಿಸ್ಟಲೇಷನ್ ಟೆಂಪರೇಚರ್ ಹೀಟ್ ಮಾಡಿ ವರ್ಕ್ ಮಾಡಿದ್ರೆ ಹಾಟ್ ವರ್ಕಿಂಗ್ ಅಂತ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ಕ್ಲಾಸಿಫೈಡ್. ಸೊ ಬೇಸಿಕಲಿ ವೆನ್ ವಿ ಡೂ ದ ಹಾಟ್ ವರ್ಕಿಂಗ್ ಏನಾಗುತ್ತೆ, ಜಾಸ್ತಿ ಹೀಟ್ ಮಾಡಿದಷ್ಟು ಪ್ಲಾಸ್ಟಿಕಲಿ ಈಸಿ ಟು ಡಿಫಾರ್ಮ್ ದ ಮೆಟೀರಿಯಲ್. ಬಟ್ ಕೋಲ್ಡ್ ವರ್ಕ್ ಅಲ್ಲಿ ಇಟ್ ರಿಕ್ವೈರ್ಡ್ ಡಿಫಿಕಲ್ಟ್ ಬಿಕಾಸ್ ಏನಾಗುತ್ತೆ, ಇಟ್ ರಿಕ್ವೈರ್ಡ್ ಲಾಟ್ ಆಫ್ ಫೋರ್ಸ್. ಮೆಟೀರಿಯಲ್ ಹೀಟ್ ಮಾಡ್ತಾ ಏನಾಗುತ್ತೆ, ಸಾಫ್ಟ್ ಆಗುತ್ತೆ. ಸೊ here we talking about what are the types of farming process. Different types of farming process are, one is forging process, rolling process, extrusion. And you know what is forging also, right? Forging andre eno? So we are going to heat the material above the recrystalline temperature, then we put up in a dies and we apply the force on that. Therefore what is happened, it will take up the deformation. Iga tell me, forging baradu hot working or cold working?
Hot working. Okay.
Yes, good.
Metal to flow into the shape of the dies. Objects produced using forging can have improved mechanical properties compared to objects which are cast. But it can be difficult to achieve tight tolerances using forging, and the required equipment can be expensive.
Yes, these are the advantage and disadvantage. One, the mechanical property improve because we are going to heat up the more recrystalline temperature in the. But thing is, tolerance achieve madakagala because it require larger the force apply in the that cannot be easily achieved. And equipment what we are using, it's quite expensive. Next, art working bandu extrusion.
Extrusion provides an excellent surface of metal in it, and the required equipment can be expensive. Extrusion is a continuous process which involves placing hot metal in a chamber and using a ram to force it through a die.
So here in extrusion means what will happen, there is a die will be there. Inside the die, here it is called die and this is called container. Now they are going to place the they are going to heat up initially the metal, that is a metal block, and they are going to apply the force using a ram. And what will happen, because of this force, the metal is going to be extruded through the die. This is called extrusion process.
With a constant cross section, extrusion provides an excellent surface finish and can achieve very tight tolerances, but it is only suitable for producing two-dimensional shapes.
Yes.
Pressure and reduce.
Next type of hot working process, most of things they are going to use called rolling.
Forming process. It involves passing metal between two or more rollers, which apply pressure and reduce.
So as its name indicates, here there are two rollers will be there. In between the roller, they are going to place the metal sheet. Before going to take up that rolling action, they are going to heat up the material. So that is above the crystallization temperature. Recrystallization temperature.
More complex products like I-beams can also be manufactured by rolling.
So I-channels, adella railway rails ideyalla, adella they are going to manufacture this using rolling things. So the advantages are improve the mechanical property, can be easily automated. But the thing is, what we are using the rolls, rollers made up of high strength material. That is very cost, and it required lot of driving members like motors adrinda.
Let's move on to the next category of manufacturing process.
This much is the comes under farming. That is few. Next is the casting.
Casting involves pouring molten metal into a mold and allows.
So you know what is the casting? Basically, we are going to heat up the metal to convert that solid metal into a molten metal. Then we are going to pour in a mold and allow it to solidify. Then the product what we'll get is called casted product.
Shaping process. A secondary process such as machining is typically needed to achieve the desired surface.
But the thing is here in the casting process, directly final product will not obtain. So first we'll get a primary shape only we'll get it. Then we need to be take out that casting product. Then we do like further processing like machining process to make a finishing. Then finally we'll get a final product.
Like forming, casting is most commonly used for metals.
So here also basically we are going to use for metals only.
Some types of casting are die casting.
There are different types of casting what he is explaining here. So one is basically basic important only he is explaining here. One is die casting, is sand casting, then investment casting process.
In die casting, molten metal is forced into removable metal dies at high pressure.
So basically here they are going to place the dies here. So here they are going to pour the material, and with the help of the ram they are going to force the molten material into inside the die. Then what will happen? It will be extruded inside that die and it will get a shape of the actual die shapes. That is the thing called die casting process.
Die casting is mostly used for non-ferrous metals like aluminum and.
Yes, very important thing is die casting is not meant for the ferrous material. So it is basically going to use for the non-ferrous material like that is aluminum,
which have low melting temperatures. It provides an excellent surface finish and can achieve very tight tolerances, but startup costs tend to be high, so it is.
Yes. So thing is advantages are in this die casting, excellent surface finish will get it. Close tolerance can be achieved depend upon the what type of dies we are using. That is depend on that. But the thing is high cost, high investment initial cost. Dies, it is very costly. One thing is made up of high strength material and also adana fabricate madake. And also it is required the equipments. That is also die casting equipment also very cost. That's the initial cost is that more. But the thing is it is preferable for most high production system. Easily produce the more number of parts with a minimum time. That is the advantage of that. The next famous type of casting comes under sand casting.
The sand is typically contained in two mold boxes called the cope and the drag. Molten metal is poured into the mold through a channel formed in the sand. When the metal has solidified, the cast object can be removed from the sand.
That is the thing. Basically, sand, as its main name indicates, sand casting, we are going to use as sand, molding sand. We are going to, using a molding box, we are going to ram this sand. That is called, one is called cope box, one is called drag box. And we are going to, finally, we are going to assemble. And we are going to put a risers, gate system and all. That I will going to discuss in depth in the next, after this video. And then we're going to pour the molten metal. And after, we'll allow some time to solidify. Finally, we're going to break down that molding box, and finally we'll get a casted product like this.
Sand casting can be used for a wide range of metals, including those with high melting temperatures. It can produce large and complex parts, and initial costs are very low, making it good for small production runs.
These are some advantages. Basically, this casting is meant for the produced to high temperature, which is having high melting temperature, basically for ferrous. And also any complex shape can easily produce. This is one of the voltage techniques they are going to use it in early days. Nowadays also we are going to following. So also the initial cost is very less cost. Next type of casting is most of the things they are going to use in the industry. Investment casting.
The wax tree is dipped into a slurry to create a ceramic mold. Applied to melt out the wax.
So basic thing in the investment casting, they are going to prepare the mold using a wax here. So then after it is prepared, the wax molding, then going to pour, they are going to immerse in a ceramic slurry. Then after that, they are going to expose to the heat. Obviously, what will happen? Because wax will be melt. and finally you'll get a shape of the final product. So the ceramic mold is ready now. Now they're going to pour the molten metal.
And once the casting has cooled, the mold is broken up.
So once they are going to pour the molten metal, then allow for some time to solidify. Then finally they are going to break that mold. They'll get a product. So basically, this type of investment casting used to manufacture gears, used to manufacture like types of impellers of the pumps, all those things.
Investment casting is good for parts with complex geometry and can achieve tight tolerances, but it is an expensive and time-consuming process. At the time, molding is used.
So next type of manufacturing technology is a molding.
Performing plastics.
Basically, this is a technique we are going to use to produce the product using a plastic material. So here we are going to use the melt that is involves the shaping or liquid or peelable material using a mold. Same molding technology we are going to use here, but the thing is here basically it is meant for plastic material. So here basically there are three types of molding technology we are going to follow with that: injection molding, compression molding, and as well as blow molding.
Let's look at the first two. Injection molding is the most commonly used manufacturing method for plastics. Polymer granules are fed into the hopper and a screw is used to pass them.
So basically injection molding is basically meant for to manufacture the plastic product like I told you yesterday. So electronics, the components, the body, so that all those things material they're going to made up of this injection molding technology. So basically they're going to use the plastic in the form of granular grains like balls type. So they're going to pour in a funnel that is here it is called as heater. So illi heater in screw mantle irutte, that is usually run with a motor. So illi heater irutte, it will be melting. So therefore solid is converted into a liquid form and that will be injected to the die. There is a die will be there at the end, and that liquid plastic is going to be injected on the molding, and finally it is allowed for some time to solidify, and you will get the shape of the product as per the dies. So basically most material going to use for here is thermoplastics, what is saying. I think you've seen one of the project, finally project last time we they done, and we exhibited also during the open day. The same thing is injection molding technology.
Are very high due to the expensive molds, so it is really only cost effective for large production runs. Flows in pressure and temperature are applied.
Next thing is the compression molding.
Compression molding involves placing a precise amount of material into a mold. The mold is closed and pressure and temperature are applied.
It's same thing as like a die molding only, but the thing is here instead of their metal they are going to use, but here we are going to use the plastic. So here we are not going to completely melt the plastic here. They are going to heat up to the like a molten, like in between like a neither be solid state in neither be in the liquid state. So athara ee salpa heat ಮಾಡಿ ಏನು ಮಾಡುತ್ತೆ, it becomes soft. Then they are going to place inside the mold box, then going to apply the compression force. That's why it's called compression molding. Then you'll get a shape of the product as per the dice.
Compression molding is mostly used for thermosets, which are polymers which irreversibly harden when heated. Tooling costs, so far we have relatively cheap.
So most of the all polymer plastic materials ಏನಿದೆಲ್ಲ like chairs irbodu, like it may be tables irbodu, all these things they produce uses this technology. Polymer materials use
ಮಾಡ್ತಾರೆ. It's quite a slow process and is not well suited for complex designs.
So basically simple design illa complex design beku andre you should prepare the mold molding ಏನಿದೆಯಲ್ಲ ಅದನ್ನು ಅದೇ complex design ಅಲ್ಲಿ ಮಾಡಬೇಕಾಗುತ್ತೆ, but it cost investment is become more, so that's why it is not much preferred for that. It is only preferred for the small simple product the designs. So that is the things they are saying here. The finally next type of manufacturing process is machining. You know that what is the machining process. With the help of the cutting tool we are going to remove the extra material, so for the large object to get a final product, that is called machining. And most of the things you know well about this. I don't want to take up into the much. Like there are different types of machining, like drilling process, turning process, all those things. So next thing is comes under the joining process. Basically, you have to combine the two different parts. So that is called a joining process. So here basically they're going to in the joining process, as you know, welding, riveting, brazing, soldering, all those things comes under joining process. First one is the welding.
The final category is additive manufacturing together.
So welding means with the help of electrode. So we are going to join the two dissimilar, or it may be a same material it made up of. So that is with application of heat, we are going to join the process. That is called welding. I will going to take up this welding process in depth in the next class, coming sessions. And finally, additive manufacturing. I think just now I explained you. Most of the people you know. Here we are going to, instead of removing the material, we are going to add the material layer by layer. So that is called additive manufacturing process. In that very famous, it is called as 3D printing process.
Successfully build up an object layer by layer. 3D printing is a slow process, and the range of materials which can be used is limited. As a result, it tends.
But yes, what is saying is it take up much time, depend upon the what size of the thickness of the material is required. So based on that, but now they are going to move in a much R&D in this process. They're making the 3D printing process very faster way. Almost it is equal to the near to the CNC machine. That is the things they are doing. So this is about the overview of the entire manufacturing process. Hope you got an idea in one video. Glimpse tara nanu show up ಮಾಡಿದೀಗ. Got it?
Yes, sir.
Yes, sir.
So that is one video, because 3D beautifully made it in a 3D visualization. You can understood that what type of the different types of manufacturing process. So I told you it make the interview questions ask you ಏನು process selection ಮಾಡಬೇಕು ಯಾವುದು ಅನ್ನೋಕೆ, what are the factors it depends. The basic things what we mentioned earlierly, few are the things we are discussing here. One is what type of shape and size should be produced. That is depend upon that you should select the different manufacturing process. Basically complex shape adre, as we know, we go for the casting process. Casting process also preferred for the large mass production. But ನನಗೆ complex ಇದೆ, but large ನನಗೆ ಮಿನಿಮಮ್ ಪ್ರಾಡಕ್ಟ್ ಅಷ್ಟೇ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡಬೇಕು 1 or 2 ಅಂದಾಗ ಯಾವ ಮೆಥಡ್ ನ ಪ್ರಿಫರ್ ಮಾಡ್ತೀರಾ? ಕಾಂಪ್ಲೆಕ್ಸ್ ಶೇಪ್ ಇದೆ, ಐ ಡೋಂಟ್ ವಾಂಟ್ ಟು ಮ್ಯಾನುಫ್ಯಾಕ್ಚರ್ ಮಚ್ ಲಾರ್ಜರ್ ಪ್ರೊಡಕ್ಷನ್, ಐ ವಾಂಟ್ 1 or 2, 3 ಪ್ರಾಡಕ್ಟ್, ದಟ್ಸ್ ಆಲ್.
Additive manufacturing.
ಅವಾಗ ಯಾವ ಗುಡ್ additive manufacturing. So what depend upon the quantity, we need to select the different types of manufacturing process. It may be large quantity or small quantity. Type of what material we are using, then based on that, suppose I need to manufacture the material like using a casting material, then which is manufacturing process is most preferred?
Casting
Process, good. So then surface finish, what is the dimension accuracy is required, then which is the manufacturing? Suppose I need eye accuracy, then which is most preferred?
metal removing.
Metal remove based ಅಡಿಟಿವ್ಲು ಆಗುತ್ತೆ. ಅದಕ್ಕಿಂತ ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಬರೋದು ಅಂದ್ರೆ ನಿಮಗೆ ಸ್ವಲ್ಪ ಡೈ ಕ್ಯಾಸ್ಟಿಂಗ್ ಎಲ್ಲ ಇರುತ್ತಲ್ಲ, ಅದರಲ್ಲಿ ಚೆನ್ನಾಗಿ ಸಿಗುತ್ತೆ. ಸೊ ಕ್ವಾಲಿಟಿ ಅಂಡ್ ಪ್ರಾಪರ್ಟಿ ರಿಕ್ವೈರ್ಮೆಂಟ್ಸ್, ಕಾಸ್ಟ್ ಆಫ್ ದಿ ಪ್ರಾಡಕ್ಟ್, ಬೇಸ್ಡ್ ಆನ್ ದಟ್ we need to select the different types of manufacturing process. So out of this process, we are going to take up very basic things of manufacturing process. It's one of the oldest technology of manufacturing process, which is still today we are using now. It is called as metal casting process. So what is casting? Basically, if you know all the people, what is casting means? Casting is a manufacturing process in which a liquid material is usually poured into a mold, and which contains the hollow cavity of the desired shape and then allowed to solidify. So here basically we are going to melt the material into a molten state. Then we are going to pour into a die and allow for the solidification. Finally, you'll get a product. That product is called casted product. But basically, I told you in the video also, they shown this is primary product. This is not a final product. In order to get a final product, we should go for secondary manufacturing process. That is called yaudu. Casting ಆದ್ಮೇಲೆ ನೆಕ್ಸ್ಟ್ ಇನ್ನೊಂದು ಮ್ಯಾನುಫ್ಯಾಕ್ಚರಿಂಗ್ ಪ್ರೋಸೆಸ್ ಯಾವ್ದು ಅಡಾಪ್ಟ್ ಮಾಡಬೇಕು?
Machining process.
Machining.
Metals.
Yes, good. Okay, what are the steps involved in that? So basically, there are sequence of steps that follows like this. First, ಏನ್ ಮಾಡಬೇಕು? Casting process ಮಾಡಕ್ಕೆ first we need to prepare the pattern. So what is the pattern? We're going to take up next. So pattern we need to prepare, which is usually the replica of the shape of the product what we want. That we need to prepare first. Then once you prepare the pattern, we need to prepare the mold. So then we need to select the different types of mold. Basically, casting is going to be selected with the sand mold casting process. Then finally, we need to, once the mold is ready, then we need to melt the material. Where you are going to melt the material? Elli melt madadu? Furnace. So usually which furnace they are going to prefer? Yayadu furnace. There are different furnace alla yavadu odidiralla cupola furnace, blast furnace, adalla most preferred yavadu andre cupola furnace. So then we are going to melt the material and finally we are going to pour in the mold and we allow for the solidification. Then finally once it's allowed, then first we're going to break this mold and we'll remove all the gates, riser, whatever we present on the molding box. Then further it is what like further machining process like machining we have to do, and further any heat treatment process we can do, and finally we'll go for the cleaning and finishing, and finally we'll go for the that is inspection to find the any casting defects. This is the sequence of process of sand casting. Clear?
Yes, sir.
What are the advantages of this? So the thing is, advantage of this casting process is to ಏನೇನು ಇರ್ಬೋದು ಹೇಳಿದ್ವಲ್ಲ ಅಡ್ವಾಂಟೇಜ್ ಹೇಳಿ, ನೀವೇ ಹೇಳ್ಬೇಕು ಅಡ್ವಾಂಟೇಜ್ ನನಗೆ.
We can use for complex.
Okay, complex shape can be easily produced. Good. Next.
Low cost.
Low cost. Good. Okay, fine. So molten metal flows into a small section in molten cavity, hence any complexion can be easily produced. Practically any type of material can be casted, but basically it is not any type. I can take up, this is basically ಮಾಡ್ಬೋದು, ಬಟ್ ಜನರಲ್ ಆಗಿ ಜಾಸ್ತಿ ಯೂಸ್ ಮಾಡೋದು ನಾವು ಇದು ಕ್ಯಾಸ್ಟಿಂಗ್ ಮೆಟೀರಿಯಲ್ ಯಾವ್ದು ಜಾಸ್ತಿ ಯೂಸ್ ಮಾಡೋದು ಯಾವುದಕ್ಕೆ? ಕ್ಯಾಸ್ಟ್ ಐರನ್ಗೆ. ಬಟ್ ಎನಿ ಟೈಪ್ ಆಲ್ಸೋ ವಿ ಕ್ಯಾನ್, ಬಿಕಾಸ್ ಎವ್ರಿಥಿಂಗ್ ವಿಲ್ ಬಿ ಮೆಲ್ಟ್ ನೋ, ವಿ ಕ್ಯಾನ್ ಈಸಿಲಿ ಮೇಕ್ ಇಟ್. ಸೊ ದೆನ್ also it is preferred for high production, like we can produce a mass production way, we can produce this. So any size casting can be produced like up to 200 tons. Heavy equipment like machines, leads, ships, propeller, etc. can be easily cast using this. That is the thing. Application we can use everywhere, like transport, like automobile, aerospace, railways, heavy equipment industry like construction, farming, machine tools, plant machinery, defense, household, all those things. So this is an example of that. Okay, let's come to the next. Now we'll go into the digging to the inside now. Pattern. So basically pattern is a replica of the what actually product we want. So that is a replica of that is called pattern. Basically the function of the pattern is to prepare the pattern prepares a mold cavity for the purpose of making a casting. Pattern may contain projections known as core prints. If the casting is required, a core needed to be made hollow. ಸೊ ಪ್ಯಾಟರ್ನ್ ಅಲ್ಲೇ ಏನಾಗಿರುತ್ತೆ, ಕೋರ್ ಪ್ರಿಂಟ್ಸ್ ಅಂತ ಇರುತ್ತೆ ಅದ್ರೊಳಗಡೆ. ಸೊ ಇನ್ ಆರ್ ಟು ಕ್ರಿಯೇಟ್ ಎನಿ ಹೋಲ್ಸ್ ಏನಾದ್ರು ಬೇಕು ಅಂದ್ರೆ, ಸೊ ಪ್ಯಾಟರ್ನ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಪ್ರಿಪೇರ್ ಕಂಟೈನ್ ದ ಕೋರ್ ಪ್ರಿಂಟ್ಸ್. ಮತ್ತೆ ಇನ್ನೊಂದು ಏನಂತಂದ್ರೆ ಫಂಕ್ಷನ್ ರನ್ನರ್, ಗೇಟ್ಸ್ ಅಂಡ್ ರೈಸರ್ ಯೂಸ್ ಇಟ್ ಟು ಫೀಡ್ ದ ಮಾಲ್ಟನ್ ಮೆಟಲ್ ಇನ್ ದ ಮೋಲ್ಡ್ ಕ್ಯಾವಿಟಿ ಮೇ ಫಾರ್ಮ್ ಎ ಪಾರ್ಟ್ ಆಫ್ ದಿ ಪ್ಯಾಟರ್ನ್. ಸೊ ದಟ್ ಥಿಂಗ್ ಇಸ್ ಇಯರ್ ರನ್ನರ್, ದಟ್ ಈಸ್ ವಾಟ್ ವಿ ಡಿಸ್ಕಸಿಂಗ್ ನೆಕ್ಸ್ಟ್, ಪಾರ್ಟ್ಸ್ ಏನೇನು ಬರುತ್ತೆ ಮೋಲ್ಡಿಂಗ್ ಅಲ್ಲಿ ಅಂತ. ಸೊ ವಿ ನೀಡ್ ಟು ಫೀಡ್ ದ ಮಾಲ್ಟನ್ ಮೆಟಲ್ಗೆ. ಸೊ ಅದು ಒಳಗಡೆ ಹೋಗ್ಬೇಕು ಅಂತಂದ್ರೆ ವಿ ಹ್ಯಾವ್ ದ ಸಿಸ್ಟಮ್ ಲೈಕ್ ಎ ಪೈಪಿಂಗ್ ಸಿಸ್ಟಮ್ ತರ ಏನಿರುತ್ತೆ, ರನ್ನರ್ ಇರುತ್ತೆ, ಗೇಟ್ಸ್ ಇರುತ್ತೆ. ಸೊ ಈಸ್ ಎ ಪಾರ್ಟ್ ಆಫ್ ಪ್ಯಾಟರ್ನ್ ಅಲ್ಲಿ ಅದನ್ನ ಆ ಪ್ಯಾಟರ್ನ್ ಮೇಲ್ಗಡೆ ಇದನ್ನೆಲ್ಲ ಫಿಕ್ಸ್ ಮಾಡೋದು. ಸೊ ದಟ್ ಈಸ್ ಅ ಪ್ಯಾಟರ್ನ್, ದಟ್ಸ್ ವೈ ಪ್ಯಾಟರ್ನ್ ಇಸ್ ರಿಕ್ವೈರ್ಡ್. ಸೊ ಪ್ಯಾಟರ್ನ್ಸ್ ಪ್ರಾಪರ್ಲಿ ಮೇಡ್ ಹ್ಯಾವಿಂಗ್ ಫಿನಿಶ್ಡ್ ಸ್ಮೂತ್ ಸರ್ಫೇಸಸ್ ರೆಡ್ಯೂಸ್ ದ ಕ್ಯಾಸ್ಟಿಂಗ್ ಡಿಫೆಕ್ಟ್ಸ್. ಸೊ ಹೌ ಬೆಸ್ಟ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಮ್ಯಾನುಫ್ಯಾಕ್ಚರ್ ದ ಪ್ಯಾಟರ್ನ್, ಬೇಸ್ಡ್ ಆನ್ ದಟ್ ವಿಲ್ ಗೆಟ್ ಎ ಸರ್ಫೇಸ್ ಫಿನಿಶ್. ಸೊ ಪ್ಯಾಟರ್ನ್ ಮೆಟೀರಿಯಲ್ ಬೇಸಿಕಲಿ ಕೇಳ್ತಾರೆ ಏನೇನಲ್ಲಿ ಮಾಡ್ಬೋದು ಅಂತ. ವುಡ್ ಇರ್ಬೋದು, ಮೆಟಲ್ ಇರ್ಬೋದು, ಪ್ಲಾಸ್ಟಿಕ್ ಇರ್ಬೋದು, ಪ್ಲಾಸ್ಟರ್ ಇರ್ಬೋದು, ವ್ಯಾಕ್ಸ್ ಇರ್ಬೋದು, ದೇರ್ ಆರ್ ಥಿಂಗ್ಸ್. ಅದ್ರಲ್ಲಿ ಜಾಸ್ತಿ ಮಾಡೋ ಮೆಟೀರಿಯಲ್ ಯಾವುದು ಪ್ಯಾಟರ್ನ್?
Wood.
Okay, because cheapest material. So advantages this wood is to ಚೀಪ್, ಈಸಿಲಿ ಅವೈಲೇಬಲ್, ಲೈಟ್ ಆ್ಯಂಡ್ ವೆಯ್ಟ್ ಇರುತ್ತೆ. ಬಟ್ ಡಿಸಡ್ವಾಂಟೇಜ್ ಇರುತ್ತೆ ಆಬ್ವಿಯಸ್ಲಿ. ಮಾಯ್ಶ್ಚರ್ ಎಫೆಕ್ಟ್ ಆಗುತ್ತೆ, ಇಟ್ ವಿಲ್ ಅಬ್ಸರ್ವ್ ದ ಮಾಯ್ಶ್ಚರ್. ಸೊ ದಟ್ ಈಸ್ ದ ಥಿಂಗ್. ಆ್ಯಂಡ್ ವೇರ್ ಆ್ಯಂಡ್ ಟೇರ್ ಆಗುತ್ತೆ ಸ್ವಲ್ಪ. ಸೊ ಆ್ಯಂಡ್ ವಿಲ್ ನಾಟ್ ಗೆಟ್ ಮಚ್ ಫಿನಿಶಿಂಗ್ ಸಮಟೈಮ್ಸ್. ದಟ್ ಈಸ್ ದ ಥಿಂಗ್. So metals, we are going to use the metals like cast iron, aluminum, ferrous, brass, all those things. But the thing is most expensive. That is the things. Like metal patterns, commonly used for pattern making like cast iron, steel, white metal, all those things. And what is the advantage of this metal pattern? It will not absorb any moisture. More stronger than the wood, obviously. Possess much longer life, good machinability. Provide more surface finish better than this. Plastics also they are going to use for some few applications, but not for everything. So low weight will be there, easy to formability, any shapes ke easy ag ಮಾಡಬಹುದು. Obviously corrosion resistance irutte, it will not affect any moisture. So basically we are going to use the epoxy resin, few foam, we are going to use a plastic material. Then plaster also we are going to use like plaster of Paris, usually called as gypsum. That is also we are going to use it. But basically gypsum is used to, ಎಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತಾರೆ gypsum ಜಾಸ್ತಿ ಹೇಳ್ತೀರಾ? ಪ್ಲಾಸ್ಟರ್ ಆಫ್ ಪ್ಯಾರಿಸ್ ಅಂತ ಹೇಳಿದ್ನಲ್ಲ, ಎಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತಾರೆ?
ಬೋನ್ಸ್ ಫ್ರಾಕ್ಚರ್ ಆದಾಗ POP.
Yes, POP. That is the thing. Good. Then also wax they are going to use it. So but ಜಾಸ್ತಿ ಯೂಸ್ ಮಾಡೋದು ಮೆಟಲ್ಸ್ ಮತ್ತೆ ವುಡ್. ಅದರಲ್ಲಿ ಜಾಸ್ತಿ ಪ್ರಿಫರ್ಡ್ ಲಾಂಗ್ ಲಾಸ್ಟಿಂಗ್ ಲೈಫ್ಗೆಲ್ಲ ಮೆಟಲ್ ಇಸ್ ಮೋಸ್ಟ್ ಪ್ರಿಫರ್ಡ್. And very important thing is the entry point of view. Next thing is a pattern allowance. So what is allowance? What is the requirement allowance? What are its types and what are its purpose? ಅದನ್ನು ಕೇಳ್ತಾರೆ. So allowance ಅಲ್ಲಿ ಬಂದು there are different types of allowance like shrinkage allowance, draft allowance, machining allowance, distortion allowance, wrapping allowance. I think now you have to tell me the answer. What is shrinkage allowance? See how like allowance ಏನಕ್ಕೆ ಬೇಕು ಅಂದ್ರೆ like machining ಅಲ್ಲೂ ಅಷ್ಟೇ ಅಲ್ವಾ allowance ಕೊಡ್ತೀವಿ, like it's called tolerance. But here also we require allowance because actual product size na ನಾವು produce ಮಾಡಕ್ಕಾಗಲ್ಲ. That's why we should basically pattern is always made larger than the final casting because it carries certain allowance due to metallurgical and mechanical reasons. ಒಂದು ಏನಕ್ಕೆ ಅಂತಂದ್ರೆ ಮೆಟಲಜಿಕಲ್ ಪ್ರಾಪರ್ಟಿ ಚೇಂಜ್ ಆಗುತ್ತೆ ಕ್ಯಾಸ್ಟಿಂಗ್ ಮಾಡ್ಬೇಕಾದ್ರೆ, ಅದಕ್ಕೋಸ್ಕರ ಅಲೈನ್ಸ್ ಕೊಡ್ಲೇಬೇಕು. ಅದರಿಂದ ಯೂಶಲಿ ಪ್ಯಾಟರ್ನ್ ಸೈಜ್ ಯಾವಾಗ್ಲೂ ಆಕ್ಚುಯಲ್ ಸೈಜ್ ಆಫ್ ದಿ ಪ್ರಾಡಕ್ಟ್ ಗಿಂತ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಮತ್ತು ಮೆಕ್ಯಾನಿಕಲ್ ಪ್ರಾಪರ್ಟಿ ಚೇಂಜ್ ಆಗೋದ್ರಿಂದ, ಯಾಕೆ ಮೆಕ್ಯಾನಿಕಲ್ ಪ್ರಾಪರ್ಟಿ ಚೇಂಜ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ ಹೀಟಿಂಗ್ ಮಾಡ್ತೀವಲ್ಲ ನಾವು, ಮೋಲ್ಟನ್ ಸ್ಟೇಟ್ ಅಂದ್ರೆ ವಾಟ್ ಇಸ್ ಅಬೌವ್ ದ ರೀಕ್ರಿಸ್ಟನ್ ಟೆಂಪರೇಚರ್. ಅವಾಗ ಆಬ್ವಿಯಸ್ಲಿ ಏನಾಗುತ್ತೆ, ಮೆಟೀರಿಯಲ್ ಮೆಕ್ಯಾನಿಕಲ್ ಪ್ರಾಪರ್ಟಿ ಲೈಕ್ ಸ್ಟ್ರೆಂತ್ ಚೇಂಜ್ ಆಗ್ಬೋದು, ಹಾರ್ಡ್ನೆಸ್ ಚೇಂಜ್ ಆಗ್ಬೋದು, ಬ್ರಿಟಲ್ನೆಸ್ ಚೇಂಜ್ ಆಗ್ಬೋದು. ದಟ್ ಇಸ್ ವೈ ವಿ ನೀಡ್ ಟು ಡಿಸೈಡ್ ವಾಟ್ ಮೇ ಬಿ ದ ಅಲೈನ್ಸ್. ದಟ್ ದಿಸ್ ಇಸ್ ದ ಒನ್ ಆಫ್ ದ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಪ್ಯಾರಾಮೀಟರ್ ವೆನ್ ಯು ಡಿಸೈನಿಂಗ್ ಎ ಮೋಲ್ಡ್. So ಅದನ್ನೆಲ್ಲ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಆಗಿ ಕನ್ಸಿಡರ್ ಮಾಡ್ತಾರೆ. So now let's start with the allowance now. That is called shrinkage allowance. Can you tell me anyone what is shrinkage allowance?
There must be some space left in case the metal shrinks after solidification.
Yes. Good. Okay. So almost all cast materials shrink or contract volumetrically on cooling. Obviously, right? ಏನಾಗುತ್ತೆ, ನಾವು ಈಗ ಫಸ್ಟ್ ಇನಿಷಿಯಲಿ ಪೋರ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, ಮೋಲ್ಡ್ ಬಾಕ್ಸ್ ಫಿಲ್ ಆಗುತ್ತೆ. ಆದ್ರೆ ಆಫ್ಟರ್ ಸಮ್ ಸಾಲಿಡಿಫಿಕೇಶನ್ ಆಗುತ್ತೆ, ಸೊ ಇನ್ನು ಗ್ಯಾಪ್ ಇಟ್ ವಿಲ್ ಬಿ ಲೆಫ್ಟ್ ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ, ಸಿಂಕ್ ಆಗುತ್ತೆ. ಸೊ ನೌ ವಿ ನೀಡ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ವಾಟ್ ಮೇ ಬಿ ದ shrink allowance now here. So shrinkage allowance gives to the pattern to compensate for the contraction of the leak metal on cooling. ಸೊ ಅದನ್ನು ಕಾಂಪನ್ಸೇಟ್ ಮಾಡೋಕ್ಕೆ ಎಷ್ಟು ಅಲೈನ್ಸ್ ಕೊಟ್ಟಿರಬೇಕು ಅನ್ನೋದನ್ನ ವಿ ನೀಡ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಡ್ಯೂರಿಂಗ್ ದ ಡಿಸೈನ್ ಆಫ್ ಎ ಪ್ಯಾಟರ್ನ್. ಸೊ ಫಾರ್ ದಿಸ್ ಡೈಮೆನ್ಷನ್ ಆಫ್ ದ ಪ್ಯಾಟರ್ನ್ ಇಸ್ ಮೇಡ್ ಸ್ಲೈಟ್ಲಿ ಓವರ್ ಸೈಜ್. ಯಾಕೆ ಓವರ್ ಸೈಜ್ ಮಾಡ್ಬೇಕಂದ್ರೆ ಬಿಕಾಸ್ ಆಫ್ ದಿಸ್. ಸೊ ದ shrinkage allowance ವಿಲ್ ಬಿ ಡಿಫ್ರೆಂಟ್ ಫಾರ್ ಡಿಫ್ರೆಂಟ್ ಮೆಟಲ್ಸ್ ಆಬ್ವಿಯಸ್ಲಿ. ಯಾಕೆಂದ್ರೆ shrinkage ಯಾವ್ದು ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ ಮೆಟೀರಿಯಲ್ ಪ್ರಾಪರ್ಟಿ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ. ಮೆಟೀರಿಯಲ್ ಪ್ರಾಪರ್ಟಿ ಡಿಫ್ರೆಂಟ್ ಮೆಟಲ್ಗೆ ಡಿಫ್ರೆಂಟ್ ತರ ಬಿಹೇವಿಯರ್ ಇರುತ್ತೆ. ಅದರಿಂದ shrinkage allowance ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಾದ್ರೆ ಇಟ್ ಡಿಪೆಂಡ್ ಅಪಾನ್ ದ ಫ್ಯಾಕ್ಟರ್ಸ್. ಮೇನ್ಲಿ ವಿ ನೀಡ್ ಟು ಕನ್ಸಿಡರ್ ದ ವಾಟ್ ಟೈಪ್ ಆಫ್ ಮೆಟೀರಿಯಲ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಕ್ಯಾಸ್ಟಿಂಗ್. ಸೊ ದಟ್ ಇಸ್ ದ ಥಿಂಗ್ಸ್. ಸೊ ಯೂಶಲಿ shrinkage allowance ಇಸ್ ಗ್ರೇಟರ್ ಫಾರ್ ಕ್ಯಾಸ್ಟ್ ಸ್ಟೀಲ್ ದ್ಯಾನ್ ದಿ ಅದರ್ ಅಲಾಯ್ಸ್. shrinkage allowance ಜಾಸ್ತಿ ಕ್ಯಾಸ್ಟ್ ಸ್ಟೀಲ್ಗೆ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಸೊ shrinkage allowance is always added along the length than along the diameter. So ಯಾವಾಗಲೂ diameter ಗಿಂತ ವರ್ಕ್ ಪೀಸ್ diameter ಗಿಂತ shrinkage allowance ನ ಲೆಂತ್ ಗೆ ಆಡ್ ಮಾಡ್ತಾರೆ. So that is the things. This table will talk about what are the types of material ಗೆ ಎಷ್ಟು shrinkage allowance ಕೊಡಬೇಕು ಅನ್ನೋದು. Up to some dimension like cast iron up to 2 feet ಆದ್ರೆ ಇಷ್ಟು ಇಂಚ್ ಡೈಮೆನ್ಷನ್ ಫರ್ ಫೀಟ್ 0.125, 2 to 4 feet ಆದರೆ 0.105, ಓವರ್ 4 feet ಆದರೆ ಇಷ್ಟು. ಸೊ ಅದೇ ಥರ ಡಿಫ್ರೆಂಟ್ ಮೆಟೀರಿಯಲ್ಗೆ ವಿ ನೀಡ್ ಟು ಗಿವ್ ಡಿಫ್ರೆಂಟ್ ಟೈಪ್ಸ್ ಆಫ್ ಅಲೈನ್ಸಸ್. ಸೊ ಅದರಲ್ಲಿ ತುಂಬ ಹೈಯೆಸ್ಟ್ ಇರೋದು ಯಾವ ವ್ಯಾಲ್ಯೂ? ಕ್ಯಾಸ್ಟ್ ಇಸ್ ದ ಹೈಯೆಸ್ಟ್. ಕ್ಲಿಯರ್? So then we'll go for machining alliance. I think you can explain, anyone, machining alliance ಏನಕ್ಕೆ ಅಂತ. ಕ್ವಿಕ್ ಆಗಿ ಹೇಳ್ಬೇಕು ನನಗೆ. ಶುಡ್ ನಾಟ್ ಟೇಕ್
In case of
ಇದನ್ನ ತುಂಬಾ ಹೇಗೆ ಫಾಸ್ಟ್ ಮಾಡಿ ನಿಮ್ಗೆಲ್ಲ ಇದು ಓದಿದ್ದೀರಾ, ಇವಾಗ ಬ್ರಷ್ ಅಪ್ ತರ ಅಷ್ಟೇ. ಹಾಗಾಗಿ ನಾನು ಹೇಳ್ತಾ ಇದ್ದೀನಿ, ಅಂದ್ರೆ ವೆರಿ ಈಸಿಯಸ್ಟ್ ಟಾಪಿಕ್ ಅಲ್ವಾ, ಇದು ಗೊತ್ತಿರುತ್ತೆ ನಿಮಗೆ. ಬಟ್ ಇವಾಗ ಮರ್ತಿರ್ತೀರಾ, ಬಿಕಾಸ್ ಯು ಐ ಥಿಂಕ್ ಯು ಸ್ಟಡಿಡ್ ಇನ್ 3rd sem ಅಲ್ಲ. ಹಾಗಾಗಿ ಸೊ ಹೇಳ್ಬೇಕೀಗ machining alliance. What is the alliance of this machining? What is required? Why it is required?
so we cannot produce exact dimension.
Yes, basically some ಯಾರು ಹೇಳ್ತಾ ಇದ್ರು ಏನು?
So we cannot produce exact dimension while machining.
Okay. Any others? Okay, this allowance is provided on the pattern if the casting is to be machined. This allowance is given to in addition to shrinkage allowance. So usually ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ಕ್ಯಾಸ್ಟಿಂಗ್ ಪ್ರಾಡಕ್ಟ್ ಫೈನಲ್ ಪ್ರಾಡಕ್ಟ್ ಅಲ್ಲ. ವಿ ನೀಡ್ ಟು ಗೋ ಫಾರ್ ಸೆಕೆಂಡ್ ಮೆಷಿನಿಂಗ್ ಪ್ರೋಸೆಸ್. ಸೊ ಅದಕ್ಕೋಸ್ಕರ ನಾವು ಒಂದು ಅಲೈನ್ಸ್ ಕೊಡ್ಲೇಬೇಕು ಅದಕ್ಕೆ. ಸೊ ಈಗ 10 mm ಡಯಾಮೀಟರ್ ಬೇಕು ಅಂತಂದ್ರೆ ಅದಕ್ಕೆ ಒಂದು ಎಕ್ಸ್ಟ್ರಾ ಅಲೈನ್ಸ್ ಫಾರ್ ದ ಮೆಷಿನಿಂಗ್ ಎಷ್ಟು ಅಂತ ನಾವು ವಿ ನೀಡ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್. ಸೊ ದಟ್ ಅಲೈನ್ಸ್ ವಿ ನೀಡ್ ಟು ಬಿ ಗಿವ್ ಫಾರ್ ದ ಫಿನಿಶಿಂಗ್ ಪರ್ಪಸಸ್. ಸೊ ಇಲ್ಲಿ ಡಿಪೆಂಡ್ ಅಪಾನ್ ದ ಅಗೇನ್ ಸೈಜ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ ಇದು ವೇರಿಯೇಷನ್ ಆಫ್ ದಿ ಅಲೈನ್ಸ್ ಅಂಡ್ ಆಲ್ಸೋ ಫಿನಿಶಿಂಗ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ. ಯೂಶಲಿ ಮೆಷಿನಿಂಗ್ ಅಲೈನ್ಸ್ ಇನ್ನೊಂದು ಏನಕ್ಕೆ ಬೇಕು ಅಂದ್ರೆ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಸರ್ಫೇಸ್ ರಫ್ ಆಗಿರುತ್ತೆ ಯಾವಾಗಲೂ. ಕ್ಯಾಸ್ಟಿಂಗ್ ಬಿದ್ದ ಪ್ರಾಡಕ್ಟ್ ಸೇಮ್ ಇರಲ್ಲ, ಫಿನಿಶ್ ಸ್ಮೂತ್ ಇರಲ್ಲ. ಅವಾಗ ನಾವು ವಿ ನೀಡ್ ಟು ಕ್ಯಾರಿ ಔಟ್ ದಿ ವಾಟ್ ಇಸ್ ದಟ್ ಕಾಲ್ಡ್ ಫಿನಿಶಿಂಗ್ ಪ್ರೋಸೆಸ್ ಲೈಕ್ ಗ್ರೈಂಡಿಂಗ್ ಇರ್ಬೋದು, ಬಫಿಂಗ್ ಇರ್ಬೋದು, ಆ ಥರ ಎಲ್ಲ ಮಾಡಬೇಕಾಗುತ್ತೆ. ಅಂಡ್ ಆಲ್ಸೋ ಇಲ್ಲಿ ಏನಾಗಿರುತ್ತೆ, ಕನೆಕ್ಟ್ ಆಗಿರುತ್ತೆ ಎಲ್ಲ ಗೇಟ್ ಸಿಸ್ಟಮ್ಸ್, ರೈಸರ್ಸ್. ಅದು ಓಪನ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, ಅದ್ರ ಕೆಲವು ಅಲ್ಲೇ ಅದ್ರ ಮೇಲೆ ಇದಾಗಿರುತ್ತೆ, ಏನು ಸ್ಟಿಕನ್ ಆಗಿರುತ್ತೆ, ಅಂದ್ರೆ ಮೋಲ್ಡಿಂಗ್ ಜೊತೆನೆ ಮೋಲ್ಡ್ ಆಗ್ಬಿಡುತ್ತೆ ಸ್ವಲ್ಪ. ಅವಾಗ ಏನಾಗುತ್ತೆ, ರಫ್ ಸರ್ಫೇಸ್ ಕ್ರಿಯೇಟ್ ಮಾಡುತ್ತೆ. ಅದಕ್ಕೋಸ್ಕರ ಇದೆಲ್ಲ ನಾವೇನ್ ಮಾಡ್ಬೇಕು, ಸೊ ಇಟ್ ಈಸ್ ಯು ವಿಲ್ ನಾಟ್ ಗೆಟ್ ಎಕ್ಸಾಕ್ಟ್ ಶೇಪ್. ಸೊ ವಿ ನೀಡ್ ಟು ಗೋ ಫಾರ್ ದ ಸೆಕೆಂಡರಿ ಮೆಷಿನಿಂಗ್ ಪ್ರೋಸೆಸ್ ಓನ್ಲಿ. ಇಟ್ ಈಸ್ ಮ್ಯಾಂಡೇಟರಿ, ವಿ ನೀಡ್ ಟು ಗಿವ್. ದಟ್ ಈಸ್ ದ ರೀಸನ್ ವಿ ಶುಡ್ ಪ್ರೊವೈಡ್ ದಿಸ್ ಮೆಷಿನಿಂಗ್ ಅಲೈನ್ಸ್. ನೆಕ್ಸ್ಟ್ ಒನ್ ಇಸ್ ದ ಡ್ರಾಫ್ಟ್ ಅಲೈನ್ಸ್ ಆರ್ ಟೇಪರ್ ಅಲೈನ್ಸ್. ಕೆನ್ ಯು ಎನಿವನ್ ಏನಕ್ಕೆ ಅಂತ?
Sir, taper is provided on the pattern for easy removal of the pattern from the casting.
Yes, good. So taper means basically you can see here, if I made the pattern like straight, so what will happen when you remove it, it become very difficult. That time what will happen, it may damage the product also. But instead of that, if I made it like some like conical like taper shape, it is easy to remove it. Therefore we need to provide some allowance here, that's called draft angle. So that angle, how much angle you need to give, that is usually from the range from ಕೇಳ್ತಾರೆ, ಒಂದು ರೇಂಜ್ ಹೇಳ್ಬೇಕು ನೀವು. ಸುಮ್ಮನೆ ಆಮೇಲೆ 10 degree 5 degree ಅಂತೆಲ್ಲ ಹೇಳ್ಬಾರ್ದು, ಸುಮ್ಮನೆ ಏನೋ ಬಾಯ್ ಬಂದಾಗೆ. ಸೊ ಯೂಶಲಿ 1 to 2 3 degree ನ ಪ್ರಿಫರ್ ಮಾಡ್ತಾರೆ ಫಾರ್ ವುಡನ್ ಪ್ಯಾಟರ್ನ್ಸ್ ಅದಕ್ಕೆ. ಅಂಡ್ ಮೆಟಲ್ಗೆಲ್ಲ ಇಲ್ಲಿದೆ, ಇದೆಲ್ಲ ಟೇಬಲ್ ಎಲ್ಲ ಇದೆ, ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಇದೆಲ್ಲ. ಸೊ 1 to 2 4 to 8 ಡಿಪೆಂಡ್ ಅಪಾನ್ ಹೈಟ್, ಇದ್ರ ಮೇಲೆಲ್ಲ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ. ಅದ್ರ ಪ್ರಕಾರ ಈ ಡ್ರಾಫ್ಟ್ ಆಂಗಲ್, ಇಂಟರ್ನಲ್, 2 ತರ ಆಂಗಲ್ ಕೊಡ್ಬೇಕು ಇಲ್ಲಿ. ಒಂದು ಎಕ್ಸ್ಟರ್ನಲ್ ಎಷ್ಟು, ಒಂದು ಇಂಟರ್ನಲ್ ಎಷ್ಟು ಅಂತ. ಡಿಪೆಂಡ್ ಅಪಾನ್ ದ ಆಬ್ಜೆಕ್ಟ್ ಪ್ರಾಡಕ್ಟ್ ಹೈಟ್ ಮೇಲೆ ಈ ಡ್ರಾಫ್ಟ್ ಆಂಗಲ್ ಏನಾಗುತ್ತೆ, ಚೇಂಜಸ್ ಆಗುತ್ತೆ. ಸೊ ದಟ್ ಇಸ್ ದ ಥಿಂಗ್ಸ್. ನೆಕ್ಸ್ಟ್ ಡಿಸ್ಟಾರ್ಷನ್ ಅಲೈನ್ಸ್. ಎನಿವನ್? ಹಲೋ, ಡಿಸ್ಟಾರ್ಷನ್ ಹೇಳ್ತೀರಾ ಯಾರು? ಆದರ್ಶ್, ಎಷ್ಟು ಜನ ಇದ್ದಾರೆ ಲೈನಲ್ಲಿ? ಓಕೆ, ಅಂದ್ರೆ ಎಲ್ಲ ನಿಮ್ಮ ಕ್ಲಾಸ್ ಅವರೇನಾ ಇಲ್ಲ ಜೂನಿಯರ್ಸ್ ಇದ್ದಾರ? ಫೈನ್, ಗುಡ್. ಓಕೆ, ಹೇಳ್ತೀರಾ ಯಾರು ಡಿಸ್ಟಾರ್ಷನ್ ಅಲೈನ್ಸ್ ಅಂತ? ಓಕೆ, ಫೈನ್. ಐ ವಿಲ್ explain myself. Sometimes casting, because of their size and shape, type of metal, tend to wrap or distort during the cooling period, depending upon the cooling speed. Expecting the amount of wrappage, and a pattern may made with allowance for wrappage, it is called chamber. Example, U-shaped casting distorted during the cooling with legs diverging instead of parallel. See, ಇಲ್ಲೇನಾಗುತ್ತೆ, ಡಿಸ್ಟ್ರಾಟ್ ಆಗುತ್ತೆ. ಡಿಸ್ಟ್ರಾಟ್ ಅಂದರೆ ಚೇಂಜಿಂಗ್ ಇಟ್ಸ್ ಶೇಪ್ಸ್. ಸೊ ಏನಾಗುತ್ತೆ, ನೀವು when we pour the material, if you want to remove the material, you need to make solidification very faster way. Sometime we'll make a cooling faster. So cooling faster ಮಾಡಿದಾಗ ಏನಾಗ್ಬಿಡುತ್ತೆ, shrinkage ಬೇಗ ಆಗುತ್ತೆ and it will be distort its shapes. Like example, you can see here. Suppose ಯು ಶೇಪ್ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡಬೇಕು ಅಂದರೆ, ಬಟ್ ಡಿಸ್ಟ್ರಾಕ್ಟ್ ಆದಾಗ ಎಕ್ಸಾಕ್ಟ್ಲಿ ನಿಮಗೆ ಈ ಥರ ಯು ಶೇಪ್ ಬರಲ್ಲ. ಇಟ್ ಮೇ ಡಿಸ್ಟ್ರಾಕ್ಟ್, ಈ ಥರ ಕಾಂಟ್ರಾಕ್ಟ್ ಆಗ್ಬೋದು, ಇಲ್ಲ ಎಕ್ಸ್ಪ್ಯಾಂಡ್ ಆಗ್ಬೋದು ಲೆಗ್ಸ್. ಸೊ ಏನಾಗುತ್ತೆ, ಸಡನ್ ಕೂಲಿಂಗ್ ಆಗುತ್ತಲ್ಲ, ಸಡನ್ ಕೂಲಿಂಗ್ ಆದಾಗ ಸೊ ಕೂಲಿಂಗ್ ಕರ್ವ್ಸ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಮಾಡುತ್ತೆ ಇದ್ರ ಮೇಲೆ. ಸೊ ಅವಾಗ ಅದು ಮೆಟೀರಿಯಲ್ ಪ್ರಾಪರ್ಟಿ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ. ಸೊ ಸಡನ್ ಟೆಂಪ್ರೇಚರಿಂದ ರೂಮ್ ಟೆಂಪ್ರೇಚರ್ ತರಬೇಕು ಅಂದ್ರೆ ನಾನು ಏನಾದ್ರು ಸಡನ್ ಆಗಿ ಅಪ್ಲೈ ದ ವಾಟರ್ಸ್, ಇಫ್ ಐ ಸ್ಪ್ರೇ ದ ವಾಟರ್, ಸೊ ಅವಾಗ ಏನಾಗುತ್ತೆ, ಆ ಕೂಲೇಜ್ ಬೇಗ ಆಗೋದ್ರಿಂದ ಇಟ್ ಚೇಂಜಸ್ ಇಸ್ property and it will expand or contract take place. That is called distortion. That alliance is called distortion alliance. So next is shaking alliance. I think you can tell this. Shaking alliance ಏನದು? Shaking. ಏನು ಶೇಕಿಂಗ್ ಅಲೈನ್ಸ್ ಅಂದ್ರೆ? ಶೇಕಿಂಗ್ ಅಂತ ಹೇಳ್ತಾ ಇದ್ರಲ್ಲ, ಶೇಕಿಂಗ್ ಏನಕ್ಕೆ ಬೇಕು? ಯಾವಾಗ ಶೇಕಿಂಗ್ ಮಾಡೋದು? ಫಸ್ಟ್ ಏನ್ ಮಾಡ್ತಾರೆ, ಅದನ್ನ ಎಲ್ಲ ಕೂಲಿ ಆದ್ಮೇಲೆ ಬ್ರೇಕ್ ಮಾಡ್ಬೇಕಲ್ಲ ಮೋಲ್ಡ್, ಅವಾಗ ಸಡನ್ ಆಗಿ ಬ್ರೇಕ್ ಮಾಡಲ್ಲ. ಯಾಕಂದ್ರೆ ಸ್ವಲ್ಪ ಸ್ಟಿಕ್ ಆಗಿರುತ್ತೆ, ಈ ಗೇಟ್ಸ್ ಎಲ್ಲ ಲೂಸ್ ಆಗ್ಲಿ ಅಂತ ಏನ್ ಮಾಡ್ತಾರೆ, ಫಸ್ಟ್ ಅಪ್ಲೈ ದ ಫೋರ್ಸ್ ಅಂಡ್ ಶೇಕ್ ಇಟ್. ಸೊ ಅವಾಗ ಸ್ವಲ್ಪ ಕ್ಲಿಯರೆನ್ಸ್ ಇರಬೇಕು, ಇಲ್ಲಾಂದ್ರೆ ಡ್ಯಾಮೇಜ್ ಆಗುತ್ತೆ ಪ್ರಾಡಕ್ಟ್. ಅವಾಗೋಸ್ಕರ ದಟ್ ಅಲೈನ್ಸ್ ದೇ ವಿಲ್ ಪ್ರೊವೈಡ್. And the pattern is shaken for easily withdrawn to mold cavity, hence the casting is slightly increased in size. In order to compensate for this increase, the pattern should be initially made slightly smaller. For small and medium sized casting, this allowance can be ignored. Large sized precision casting, however, shaking allowance to be considered. Small casting adre will not going to be preferred much, but large castings ಅಲ್ಲಿ this is allowance is preferred. So ಇದರಲ್ಲಿ ಮೋಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಅಲೌನ್ಸ್ ಯಾವುದು ಅಂದ್ರೆ ಹೇಳ್ತೀರಾ? ಯಾವುದು ಇದರಲ್ಲಿ ಔಟ್ ಆಫ್ ದಿಸ್ ವಿಚ್ ಇಸ್ ಮೋಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಅಲೌನ್ಸ್?
shrinkage.
ಫಸ್ಟ್ 3 ಆರ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್, ಮಿನಿಮಮ್ ಇರಲೇಬೇಕು ಎಲ್ಲದಕ್ಕೂ ಈ 3. ಲಾಸ್ಟ್ 2 ಏನಂದ್ರೆ ಡಿಪೆಂಡ್ ಅಪಾನ್ ದ ಸೈಜ್ ಅಂಡ್ ಡಿಪೆಂಡ್ ಅಪಾನ್ ದ ಶೇಪ್, ಅದು ಪ್ರೊವೈಡ್ ಮಾಡೋದು. ಫಸ್ಟ್ 3 ಮಾತ್ರ ಕಾಮನ್ ಆಗಿ ಎಲ್ಲದಕ್ಕೂ ಕೊಡ್ಲೇಬೇಕು. ದಟ್ ಇಸ್ ದ ಥಿಂಗ್ಸ್. ದಟ್ ಈಸ್ shrinkage allowance, drafting allowance and machining allowance. That is about the allowance. Hope you got an idea about the allowance. Clear?
Sir.
Next we'll talk about what is the types of patterns. There are many types as we're discussing now, like single piece patterns, split pattern, loose piece patterns, match plate patterns, V pattern, gated, skeleton, follow board patterns, scope and drag patterns. So single piece pattern means it is usually made up of a single piece. That's why it's called solid pattern. Does not contain any loose pieces. One single piece irutte. Adana single piece pattern like this. This is a single piece pattern. Split pattern andre ಏನು?
Consists of 2 halves.
2 halves. Good. So ಒಂದೇನ 2 halves ತರ ಕಟ್ ಮಾಡಿದ್ದಾರೆ. Like in order to produce like hollow cylinder, taps, water for that. So same one single pattern ನ ಅರ್ಧ ಕಟ್ ಮಾಡಿದ್ದಾರೆ ಈಗ, ಮೇಲ್ಗಡೆ ಹಾಫ್ ಕೆಳಗಡೆ ಹಾಫ್. That is called split pattern. Loose piece pattern ಅಂದ್ರೆ so made up of different not in a single piece. So here ಏನಾಗಿರ್ತಾರೆ, there are certain pattern cannot be withdrawn once they are embedded in the molding. ಸೊ ಅಂದ್ರೆ ಒಂದೇ ಪೀಸಲ್ಲಿ ಮಾಡ್ಬಿಟ್ಟು ಒಂದೇ ಸತಿ ಎತ್ತಕ್ಕೆ ಹೋದ್ರೆ ಏನಾಗುತ್ತೆ, ಡ್ಯಾಮೇಜ್ ಆಗುತ್ತೆ. ಸೊ ಆ ಟೈಮ್ಸ್ ಎಲ್ಲ ಕಾಂಪ್ಲೆಕ್ಸ್ ಶೇಪ್ಸ್ ಇದ್ದಾಗ ಇಟ್ ಇಸ್ ವೆರಿ ಡಿಫಿಕಲ್ಟ್. ಸೊ ಅವಾಗ ಏನ್ ಮಾಡ್ತಾರೆ, ಸೆಪರೇಟ್ ಪ್ಯಾಟರ್ನ್ಸ್ ಯೂಸ್ ಮಾಡಿ ದೇ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಕಂಬೈನ್. ಅವಾಗ ಒನ್ ಪೀಸ್ ಬೈ ಪೀಸ್ ಏನಾಗುತ್ತೆ, ರಿಮೂವ್ ಮಾಡ್ತಾ ಹೋಗ್ತಾರೆ. ದಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಲೂಸ್ ಪೀಸ್ ಪ್ಯಾಟರ್ನ್ಸ್. ಸೊ ಇದಕ್ಕೆಲ್ಲ ಫಿಕ್ಸ್ ಮಾಡೋಕ್ಕೆಲ್ಲ ಪಿನ್ ಸಿಸ್ಟಮ್ ಇರುತ್ತೆ, ಡಬಲ್ ಪಿನ್ಸ್ ಅಂತ ಹೇಳ್ತಾರೆ. ಒಂದ್ರ ಮೇಲೆ ಒಂದು ಹೋಗಿ ಲಾಕಿಂಗ್ ಸಿಸ್ಟಮ್, ಇಂಟರ್ಲಾಕಿಂಗ್ ಸಿಸ್ಟಮ್ ಇರುತ್ತೆ. ದಟ್ ಈಸ್ ಯು ಕ್ಯಾನ್ ಸಿ ಲೂಸ್ ಪೀಸ್ ಪ್ಯಾಟರ್ನ್. ಸೊ ಪಿನ್ ಸಿಸ್ಟಮ್ ಆಗಿರ್ತಾರೆ. Match plate ಅಂದ್ರೆ it consists a match plate on the other side of the which each of the split pattern is fashioned. A number of different sized shaped patterns may be mounted in one match plate. The match plate is with the help of locator holes can be clamped with a drag. That you can see. So idu one match plate. Ee match plate mele different patterns na they are going to be pinned. So idu onde plate mele idella bandu combined agi assemble agutte. ಸೊ ಅದಕ್ಕೆ ಒಂದು ರನ್ನರ್ ಇರುತ್ತೆ, ಇಲ್ಲಿ ಪೋರ್ ಮಾಡಿದ್ರೆ ಈ ಪ್ಯಾಟರ್ನ್ ಒಳಗಡೆ ಎಲ್ಲ ದ ಮಾಲ್ಟನ್ ಮೆಟಲ್ ವಿಲ್ ಫ್ಲೋ. ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಮ್ಯಾಚ್ ಪ್ಲೇಟ್ ಪ್ಯಾಟರ್ನ್. Gated pattern. Gated pattern, I think you know that it consisting of different gates. The section connecting different patterns serve as a runner and gates. So ಈ ತರ. ಸೊ ಇಲ್ಲಿ ಡಿಫ್ರೆಂಟ್ ಪ್ಯಾಟರ್ನ್ಸ್ ಇದೆ, ನಂಬರ್ ಆಫ್ ಪ್ಯಾಟರ್ನ್ಸ್. ಸೊ ಈಗ ಒಂದ್ ಕಡೆ ನಾನು ಪೋರ್ ಮಾಡಿದ್ರೆ ಎಲ್ಲಾ ಕಡೆ ಫ್ಲೋ ಆಗಬೇಕು ಮೆಟಲ್. ಅದಕ್ಕೆ ಏನ್ ಮಾಡ್ತೀವಿ, ವಿ ಆರ್ ಪ್ರೊವೈಡಿಂಗ್ ಲೈಕ್ ಎ ಪಾತ್ ಗೇಟ್ ಸಿಸ್ಟಮ್ ನ ಪ್ರೊವೈಡ್ ಮಾಡ್ತೀವಿ. ಅವಾಗ ಏನಾಗುತ್ತೆ, ಸೊ ಒಂದು ಮೈನ್ ಸ್ಟ್ರೀಮ್ ಇರುತ್ತೆ, ಇಲ್ಲಿ ಸಬ್ ಸ್ಟ್ರೀಮ್. ಈಗ ಸೊ ಒಂದು ಮೈನ್ ಫ್ಲೋ, ಸೊ ಮೈನ್ ಫ್ಲೋ ಇಂದ ಪೋರ್ ಮಾಡಿದಾಗ ಇಲ್ಲೇನಾಗುತ್ತೆ, ಮೆಟಲ್ ಮಾಲ್ಟನ್ ಮೆಟಲ್ ಡಿವೈಡ್ ಆಗಿ ಫ್ಲೋ ಆಗಿ ಇಟ್ ವಿಲ್ ಗೋಸ್ ಟು ದ ಪ್ಯಾಟರ್ನ್ಸ್. ಸೊ ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ ಗೇಟ್ಸ್, like a channels, as like a channels, these are things. Next, cope and drag patterns. Basically cope, drag. So cope in the sense which is use the pattern usually in the cope upward part of the molding bus is called cope. Drag means it's the bottom part of the bus. So cope pattern andre it will go into place in the cope box ali. Drag is at the bottom. When you assemble you will get a total. Here also there is a pin system will be there to assemble properly. That is the thing. Next, sweep pattern. Basically this sweep pattern is going to use for when you produce a circular objects. Then it is going to use a pattern called a sweep pattern. Basically it is just made up of a wooden board which sweep the shape of the casting into the sand all around the circumferences. So illi I think you can see here, illi ಒಂದು ಇದಿರುತ್ತೆ, ಏನು ಪಿವೋಟ್ ಇದಿರುತ್ತೆ ಸ್ಪಿಂಡಲ್. ಇದಕ್ಕೆ ಒಂದು ಸ್ವೀಪ್ ಪ್ಯಾಟರ್ನ್ ಅಂತಂದ್ರೆ ಲೈಕ್ ಎ ಬೋರ್ಡ್ ಸಿಸ್ಟಮ್ ವಿಚ್ ಕನ್ಸಿಸ್ಟಿಂಗ್ ಆಫ್ ದ ಶೇಪ್ ಆಫ್ ದ ಬಾಡಿ. ಸೊ ವೆನ್ ದಿಸ್ ಇಸ್ ದ ಫಿಕ್ಸೆಡ್, ಇದನ್ನೇನಾಗುತ್ತೆ ಇಂಜ್ ಆಗಿರುತ್ತೆ ಇಲ್ಲಿ. ವೆನ್ ಯು ರೊಟೇಟ್ ಇಟ್ ವಿಲ್ ಕ್ರಿಯೇಟ್ ಎ ಶೇಪ್, ಸರ್ಕ್ಯುಲರ್ ಶೇಪ್. ದಟ್ ಇಸ್ ದ ಥಿಂಗ್ಸ್, ದಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಸ್ವೀಪಿಂಗ್ ಆಕ್ಷನ್, ರೊಟೇಷನ್ ಆಕ್ಷನ್. ದಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಸ್ವೀಪ್ ಪ್ಯಾಟರ್ನ್. ಸೊ ಬೇಸಿಕಲಿ ದಿಸ್ ಇಸ್ ಟು meant for to produce a symmetrical objects. ಸೊ ಸಿಮೆಟ್ರಿಕಲ್ ಅಂದ್ರೆ ಐದರ್ ಸೈಡ್ ಸೇಮ್ ಶೇಪ್ ಇರುತ್ತೆ, ಅದನ್ನ ಅದು ಯೂಶಲಿ ಸರ್ಕ್ಯುಲರ್ ಶೇಪ್ಸ್ ಅದನ್ನೇ ಹೇಳ್ತಾರೆ. ಸ್ವೀಪ್ ಪ್ಯಾಟರ್ನ್ ಇಸ್ ಪ್ರಿಫರ್ಡ್ ಫಾರ್ ಪ್ರೊಡ್ಯೂಸಿಂಗ್ ಲಾರ್ಜ್ ಕ್ಯಾಸ್ಟಿಂಗ್ ಸರ್ಕ್ಯುಲರ್ ಸೆಕ್ಷನ್ ಅಂಡ್ ವಿಚ್ ಇಸ್ ಸಿಮೆಟ್ರಿಕಲ್ ಇನ್ ಶೇಪ್. ದಟ್ ಇಸ್ ದ ಥಿಂಗ್ಸ್. ಸೊ ವಾಟ್ ಇಸ್ ಯೂಸ್ ಆಫ್ ದಿ ಸ್ವೀಪ್ ಪ್ಯಾಟರ್ನ್ ಅಂದ್ರೆ ನಾರ್ಮಲ್ ಪ್ಯಾಟರ್ನ್ ಸಿಂಗಲ್ ಪ್ಯಾಟರ್ನ್ ಮಾಡೋಕ್ಕಾಗಲ್ವಾ, ಮಾಡ್ಬೋದು. ಬಟ್ ಯಾಕೆ ಇದನ್ನ ಪ್ರಿಫರ್ ಜಾಸ್ತಿ ಯಾಕೆ ಮಾಡ್ತಾರೆ ಸರ್ಕ್ಯುಲರ್ ಬಂದಾಗ? ಯಾಕೆ? ಈಗ ಸಿಂಗಲ್ ಪ್ಯಾಟರ್ನ್ ಅಲ್ಲಿ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡ್ಬೋದಲ್ವಾ ಸರ್ಕ್ಯುಲರ್ ಆಬ್ಜೆಕ್ಟ್ ನ. ವೈ ಸ್ವೀಪ್ ಪ್ಯಾಟರ್ನ್ ಇಸ್ ಮೋಸ್ಟ್ ಪ್ರಿಫರ್ಡ್? ಸಿಂಗಲ್ ಪೀಸ್ ಪ್ಯಾಟರ್ನ್ ಸ್ಮಾಲ್ ಸೈಜ್ ಇದ್ದಾಗ ವಿಚ್ ಇಸ್ ಪ್ರಿಫರ್ಡ್, ಬಟ್ ಲಾರ್ಜರ್ ನಿಂಗ್ ಶೇಪ್ ಅಲ್ಲಿ ಬೇಕು ಅಂದಾಗ ಸ್ವೀಪ್ ಪ್ಯಾಟರ್ನ್ ಇಸ್ ಈಸಿ ಟು ಪ್ರೊಡ್ಯೂಸ್. ಹಿಂಗ್ ಸ್ವೀಪ್ ಮಾಡಿ ರೊಟೇಟ್ ಮಾಡಿದ್ರೆ ವಿಲ್ ಗೆಟ್ ಎ ಶೇಪ್. ದಟ್ ಇಸ್ ವೈ ದಟ್ ಇಸ್. ನೆಕ್ಸ್ಟ್ ಒನ್ ಇಸ್ skeleton pattern. It is in the form of skeleton. So skeleton pattern is skeleton of desired shape which may S-bend shape or sometime else. The skeleton frame is mounted on the metal base. The skeleton is made from wood strips and is this wooden one. The skeleton pattern is filled with the sand and is rammed. Image alli ತೋರಿಸಬೇಕಾಗಿದೆ ನಾನು. I think it is not visible properly. So basically skeleton ಅಂದ್ರೆ thickness ಕಡಿಮೆ ಇರುತ್ತೆ. ಸೊ ಒಳಗಡೆ ಒಂಥರ ಹಾಲೋ ಶೇಪ್ಸ್ ಇರುತ್ತೆ. ಸೊ ಅದಕ್ಕೆ ದಟ್ ಕಾಲ್ಡ್ ಆಸ್ skeleton pattern. ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ ಅದನ್ನು ಪ್ರಾಪರ್ ಆಗಿ ಶೋ ಮಾಡ್ತೀನಿ ನಿಮಗೆ ಪಿಕ್ಚರ್ ಅಲ್ಲಿ, ಅವಾಗ ನಿಮ್ಗೆ ಗೆಟ್ ಎನ್ ಐಡಿಯಾ. ಐ ಥಿಂಕ್ ನೌ ಇಟ್ ಇಸ್ ನಾಟ್ ಪಾಸಿಬಲ್. ಸೊ ಅದರಿಂದ ಇದು ಲೋ ಕಾಸ್ಟ್ ಟೈಪ್. ಅಂಡ್ ಲಾಸ್ಟ್ ಒನ್ ಇಸ್ ದ ಫಾಲೋ ಬೋರ್ಡ್ ಪ್ಯಾಟರ್ನ್. ಎ ಫಾಲೋ ಬೋರ್ಡ್ ಇಸ್ ಅ ವುಡನ್ ಬೋರ್ಡ್ ವಿಚ್ ಇಸ್ ಯೂಸ್ ಫಾರ್ ಸಪೋರ್ಟಿಂಗ್ ದ ಪ್ಯಾಟರ್ನ್ ವಿಚ್ ಇಸ್ ವೆರಿ ಥಿನ್ ಅಂಡ್ ಫ್ರಾಗಲ್. ಐ ಥಿಂಕ್ ಯು ಕ್ಯಾನ್ ಸಿ ಫಾಲೋ ಬೋರ್ಡ್. ಸೊ ಇಲ್ಲಿ ಈ ಫಾಲೋ ಬೋರ್ಡ್ ಯಾವ್ದಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತಾನೆ ಅಂತಂದ್ರೆ ದಟ್ ಯು ಕ್ಯಾನ್ ಸಿ ದಿಸ್ ಇಸ್ ದ ಫಾಲೋ ಬೋರ್ಡ್. So basically this is the follow board is used for supporting pattern which is very thin and fragile. So thin ಆಗಿರುತ್ತೆ ಸೆಕ್ಷನ್ಸ್, ಮತ್ತೆ ಫ್ರಾಗ್ರೈಲ್ ಅಂದ್ರೆ ಏನು, ಲೈಕ್ ಇನ್ ಎ ಗ್ಲಾಸ್ ನೇಚರ್. ಅಂದ್ರೆ ಸಡನ್ ಸ್ವಲ್ಪ ಫೋರ್ಸ್ ಹೊಡೆದ್ರೆ ಅದು ಬ್ರೇಕ್ ಡೌನ್ ಆಗ್ಬಿಡುತ್ತೆ. ಅದು ಯೂಶಲಿ ಥಿನ್ ಸೆಕ್ಷನ್ ಅಂದ್ರೆ ಇದು ಪ್ರಾಬ್ಲಮ್ ಇರುತ್ತೆ. ಸೊ ಅದಕ್ಕೆ ಅಂತ ಟೈಮಲ್ಲಿ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಯೂಸ್ ದಿಸ್ ಫಾಲೋ ಬೋರ್ಡ್ ವಿಚ್ ಮೇ ಗಿವ್ಸ್ ಅಂಡ್ ಕೊಲಾಪ್ಸ್ ಅಂಡರ್ ಪ್ರೆಷರ್ ವೆನ್ ಸ್ಯಾಂಡ್ ಅಬೌವ್ ದ ಪ್ಯಾಟರ್ನ್ ಇಸ್ ಬೀಂಗ್ ರ್ಯಾಮ್ಡ್. ಸೊ ಇದು ಏನ್ ಮಾಡುತ್ತೆ, ಪ್ರೊಟೆಕ್ಷನ್ ತರ ಮಾಡುತ್ತೆ ಅದನ್ನ ಇದಾಗ್ತಿದ್ದಂಗೆ, so break agreeing. That is the things. So this is the various types of patterns come across used in the casting process. And also in the pattern they are going to use the different color codes for the different purpose. Like they are going to machining color code like red. So red anta paint madidrenu machining surface madbekanta. Black anta coat madidre unmachined surface anta indicate agutte. So coloring, but next yellow madre it is called core print. Red strip on yellow base per seat for loose pattern anta. So andre adu indication easily namge. ಸೊ ಆ ಇಂಡಿಕೇಶನ್ ಈಸಿಗೆ ಆಗೋಕ್ಕೋಸ್ಕರ ಈ ಕಲರ್ ಪ್ಯಾಟರ್ನ್ಸ್ ನ ಯೂಸ್ ಮಾಡ್ತೀನಿ. ಅಂಡ್ ದಟ್ ಈಸ್ ಯೂಸ್ ಟು ಬಿ ಫಾಲೋ ವಿತ್ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಕಲರ್ ಕೋಡ್. ದಿಸ್ ಆರ್ ದ ಪ್ರಾಕ್ಟೀಸ್ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಕಲರ್ ಕೋಡ್ಸ್. And typically any mold, now we are talking about mold. So any molding box consisting of sand, that is called sand mold. What are the parts of the sand mold? ಏನೇನು ಇರುತ್ತೆ? ಹೇಳ್ತೀರಾ? ಒಂದು ಮೋಲ್ಡಿಂಗ್ ಬಾಕ್ಸ್ ಒಳಗಡೆ ಏನೇನಿರುತ್ತೆ? ಮೋಲ್ಡಿಂಗ್ ಅಂದ್ರೆ ಏನೇನಿರುತ್ತೆ?
Cope, drag, runner, riser, sprue gates.
Good. So any of the typical mold, there are two types of mold we are going to use: open mold and closed mold. So open mold only consisting of one molding box. It's open to the atmosphere basically. So here we are going to pour the material in the outside the box, or usually at the top portion. For simple, which is this one, but basically we are going to use much is when it is a shapes is complex in nature, then we prefer for the closed mold. So basically there are mold boxes divided into two halves here. One is called cope, one is drag. So drag basically is a bottom box and top is the called cope. So here inside that it is, there are going to various things we are going to connect for this, like riser, as she said, pattern, core, runners, riser, all those things, gating system, all those things. So there are two types of mold process we are going to use, basically called as expandable mold process and permanent mold process. So that is a two category in the casting process. That is expandable means use an expandable mold which is destroyed to remove the casting. So permanent means mold. So andre expandable andre eno temporary type. First casting goskara first prepare ಮಾಡ್ತಾರೆ, then once it is solidified pattern ಯಾವಾಗ casting prot ಆಗುತ್ತೋ then immediately they will break it off. That is usually sand molding, ಎಲ್ಲ expandable type. But permanent mold ಅಂದ್ರೆ ಒಂದ್ಸತಿ mold prepare ಆದ್ರೆ that it is going to use for again and again for over long periods. That is called usually ಯಾವ್ದದು? It is made up of metals. So metals ಎಲ್ಲ usually ನಾವು ಮಾಡೋದು permanent mold. ಅದು ಪದೇ ಪದೇ ಅದನ್ನ ನಾವು ಇದು ಮಾಡಲ್ಲ, ಬ್ರೇಕ್ ಮಾಡಲ್ಲ. ಬಟ್ ಇದು ಸ್ಯಾಂಡ್ mold ಎಲ್ಲ ಬಂದು ಟೆಂಪ್ರರಿ ಟೈಪ್. ಒಂದ್ಸತಿ ಪ್ರಾಟ್ ರೆಡಿ ಆದ್ಮೇಲೆ ವಿಲ್ ಗೋಯಿಂಗ್ ಟು ಬ್ರೇಕ್ ಇಟ್ ಆಫ್. ದಟ್ ಇಸ್ ದ ಥಿಂಗ್ಸ್. ಐ ಥಿಂಕ್ ಇದರಲ್ಲಿ ಇದನ್ನ ಹೇಳ್ಬೇಕಾಗಿತ್ತು. ಸೊ ಓಕೆ, ಟೆಲ್ ಮಿ ಕ್ವಿಕ್ಲಿ, ವಾಟ್ ಇಸ್ ದ ಯೂಸ್ ಆಫ್ ರೈಸರ್? ರೈಸರ್ಗಿಂತ ಫಸ್ಟ್ ಪೋರಿಂಗ್ ಕಪ್ ಏನಕ್ಕೆ ಯೂಸ್ ಹೇಳಿ? ಸ್ಪ್ರೂ ಅಂತ ಕರೀತಾರೆ ಅದನ್ನ.
To pour the metal into the cavity.
Yes, sprue is where it is connected the cup to the what is that, runner. So where that metal is going to be pour here. So it's going to be allow the metal to flow from pouring cup to the runner. What is the use of riser? Anyone?
Sir, not sure, but maybe for the gases to...
No. Any others? Good. ಅಷ್ಟೇನಾ?
ಫುಲ್ ಫಿಲ್ ಆಗಿದೆಯಾ ಅಂತ ಗೊತ್ತಾಗಲ್ಲ.
ಸೊ ಏನಾಗುತ್ತೆ, ಇಲ್ಲಿ ಮೆಟಲ್ ಪೋರ್ ಮಾಡಿದಾಗ ಇಲ್ಲಿ ರೈಸ್ ಆಗುತ್ತೆ, ಅದಕ್ಕೆ ರೈಸರ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಒಂದು ಮೆಟಲ್ ಮೋಲ್ಡಿಂಗ್ ಬಾಕ್ಸ್ ಫುಲ್ ಅದು ಫಿಲ್ಡ್ ಆಗಿದಿಲ್ಲ ಅನ್ನೋದು ಗೊತ್ತಾಗದೆ ಹೇಗೆ? ಸೊ ಆ ರೈಸರ್ ಮುಖಾಂತರ ಅಲ್ಲೇನಾಗುತ್ತೆ, ರೈಸರ್ ಮುಖಾಂತರ ರೈಸ್ ಆಗಿ ಟಾಪ್ ಸರ್ಫೇಸ್ ಬಂದಾಗ ಫುಲ್ಲು, ಅವಾಗ ದೆನ್ ವಿ ಗೆಟ್ ಟು ನೋ ಸೊ ಇದು ಫಿಲ್ ಆಗಿದೆ ಅಂತ. ಅಂಡ್ ಅದರ್ ಪರ್ಪಸ್ ಇಸ್ ಟು ಆಸ್ ಅದರ್ ಸೆಟ್ ಶ್ರಿಂಕ್ ಆದಾಗ ಪುನಃ ಏನು ಆಗುತ್ತೆ, ಗ್ಯಾಪ್ ಕ್ರಿಯೇಟ್ ಆದಾಗ ಪುನಃ ಈ ರೈಸರ್ ಇರೋ ಮೆಟೀರಿಯಲ್ ಇಲ್ ಗೋ ಫ್ಲೋ ಬ್ಯಾಕ್. ಸೊ ದಟ್ ಈಸ್ ದ ಥಿಂಗ್ಸ್. ದರ್ ಆರ್ ಟೂ ಪರ್ಪಸ್ ರೈಸ್ ಅಂಡ್ ರನ್ನರ್. ರನ್ನರ್ ಏನು ಹೇಳ್ಬೋದಲ್ಲ?
For the molten metal to pass wait
to inside a pattern. So ಇಲ್ಲಿ like a gating system ಇರುತ್ತಲ್ಲ ಅದು. Okay, fine, that is enough. So now we'll come to the sanding. Molding sanding is very important here. What type of sand we are going to use, that is very important here. We depend upon the casting type and what type of material you're going to be casting. All those things matters. Based on that, we are going to use a different types of sand. Basically, we are going to prefer for 3 types of sand: natural, synthetic, as well as special type of sand. So natural sand, it is made up of like 20% of the clay, and along with the 5 to 20% natural sand is directly used for molding, and 5 to 20% of clay as a binding material they are going to use. Natural sand, what we are using, along with that, they are going to use a 20%, 5 to 20% of the clay, enough inert for the binding purpose. So along with what we are going to use a water also to mix it, like not to create a binding property, that is 5 to 8%. So that is called natural sand. But usually natural sand we is not going to use much. We are going to use first. Next one is synthetic sand, consisting of silica sand with or without amount of clay or moisture. So that is synthetic sand is more preferable. This is mainly for the AV casting they are going to useful. For the small casting, it is natural sand is enough. But the main is called but AV casting we go for synthetic sand. So loam sand contains many ingredients like fine sand particle, fine grounded refractories like clay, graphite, fiber. So we are going to use for this. Basically, this is the things going to useful for the casting like big bells. They are going to use this loam sand. But out of this, just use the synthetic sand. It's also called as silica sand. Adana just preferred model. So what is the characteristic of this sand? The main thing is, first thing is green strength. So green and it is consisting of in a moisture state. It consisting of moisture, that is called green. Now, the first thing is we need to check green strength. The green sand after water has been mixed into a mass and with a sufficient strength should toughness and to permit make them to handling the mold. The green strength also depend upon the grain shape and size of the what type of clay and moisture content we are going to use. So green strength is very important. Green strength antandre so you got one sati mold prepare agi mix ad binding admele yes adadu strength estirutte to hold that molten in molding box alle edu kutkobekalla. Inga molding box na lift madidre it should not come out. So you should hold all the sand particles together. So that is called green strength. When green strength it depend upon the one is what is the grain size of the sand. Along with that, what is the moisture content we are going to use. That is that. Next one is the dry strength characteristic. As soon as the molten metal is poured into the mold, the moisture is then in the sand layer adjacent to the hot metal gets evaporated, and this dry sand layer must have sufficient strength to its shape in order to avoid the erosion. So sometimes so usually what will happens before the molding it will be in the green state, but when you pour the molten metal, what will happen because of that amount of heat is passed from the molten metal to the sand, so it will absorb the moisture and it get away evaporated into the atmosphere. Dry wet stand convert into a dry stand. So hot condition it should not collapse, it should hold some time to that with some strength. So adunu collapse agdane adu hage hold agi itkondirbeku. That is called a dry strength. So it is very important. Illa enagibidutte erosion agibidutte and it will be collapse. So adikke dry strength kuda very important agirutte. Very important. Flowability. Flowability means it is the ability of the sand to get compacted and behaves like a fluid. So when ramming process, right? Basically we are going to do a ramming process. So ramming means we are going to apply the pressure compression force to create a bonding action to compact the sand. So now compact so you should be compress easily. Compress easy agbeku antandre flowability jasti irbeku. So adu enagta compact agta hodastu namage strength jasti agutte. Aa flowability mele depend agirutte. That is the things like hege water flow aguttalla atara. Next, permeability. I think you know what is it. This is also very important. Permeability or porosity. It is also termed as porosity of the molding sand in the order to allow the escape of any gas. Basically, as I said, so casting process nadibekadre enagutte it will produce gases, hot gases that should be allowed to escape through that. Illandre enagbidutte it will create a problem like blowholes. So that what is the permeability property is to measure the porosity of the molding sand. Porosity andre enu? What do you mean by porosity? Porosity is the nothing but it measures the what is the gap between the each sand grains. One sand grain the ಇನ್ನೊಂದು ಗ್ರಾನ್ ಸ್ಯಾಂಡ್ ಇರೋ ಗ್ಯಾಪ್ ಏನಿರುತ್ತಲ್ಲ ಅದು. ಸೊ ಅದನ್ನ ಪೋರೋಸಿಟಿ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಈ ಪೋರೋಸಿಟಿ ಜಾಸ್ತಿ ಆದಷ್ಟು ಈಸಿಲಿ ಇಟ್ ವಿಲ್ ಅಲೋ ದ ಗ್ಯಾಸ್ ಟು ಎಸ್ಕೇಪ್. ಬಟ್ ಪೋರೋಸಿಟಿ ಜಾಸ್ತಿ ಆದ್ರೂ ಕ್ರಿಯೇಟ್ ಏನು ಪ್ರಾಬ್ಲಮ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ ಸ್ಟ್ರೆಂತ್ ಕಡಿಮೆ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. Mold strength, that is the thing. But every mold should have some permeability property to escape the hot gases. That should be very important. So usually ಅದನ್ನು ನಾವೇನ್ ಮಾಡ್ತೀವಿ, ಮ್ಯಾನ್ಯಲ್ ಕ್ರಿಯೇಟ್ ಮಾಡ್ತೀವಿ ಯೂಸಿಂಗ್ ಎ ವೆಂಟ್ ರಾಡ್. ಹಿಂಗೆ ಓಲ್ ಮಾಡಿ, ವೆಂಟ್ ರಾಡ್ ನೀವೆಲ್ಲ ಮಾಡಿದ್ದೀರಲ್ವಾ? That is the thing.
Yes, sir.
Next, refractories property. Refractories is the very important property to withstand the ability to withstand the high temperature. Basically, we are going to heat up to the 1000 degree. So ಅದನ್ನ withstand ಮಾಡ್ಕೋಬೇಕು. ಅದನ್ನ that is called refractories property. So adhesiveness. So adhesiveness is the property of molding sand to get stick or adhere with the foreign material, such sticking of molding sand with inner wall of the molding box. So it is ability to stick or adhere the foreign material. ಅಂದ್ರೆ ಇವಾಗ ಕ್ಯಾಸ್ಟಿಂಗ್ ಆಗ್ಬೇಕಾದ್ರೆ ಸಮ್ಟೈಮ್ಸ್ ಏನಾಗುತ್ತೆ, ಫಾರಿನ್ ಮೆಟೀರಿಯಲ್ಸ್ ಎಲ್ಲ ಮಿಕ್ಸ್ ಆಗಿರುತ್ತೆ, ಅದು ಇದಾಗ ಚಾನ್ಸ್ ಇರುತ್ತೆ. ಆಗ ಅದನ್ನ ಅದು ಕ್ಯಾಸ್ಟಿಂಗ್ ಪ್ರಾಡಕ್ಟ್ ಒಳಗಡೆ ಮಿಕ್ಸ್ ಆಗ್ತಿದ್ದಂಗೆ ಅದನ್ನ ಸ್ಟಿಕ್ ಮಾಡ್ಕೋಬೇಕು. ಸೊ ದಟ್ ಇಸ್ ಕಾಲ್ಡ್ adhesiveness property. Next, coziness. Coziness is the property of the molding sand by virtue of which sand grain particle interact and attract each other within the molding sand. Thus, the binding capability of molding sand gets enhanced to increase the grain. See, there are two property. I think cohesive property. Where you heard this? Cohesive antidiyalla. Cohesive innondu adhesive. So you know that cohesive and adhesive. Basically, cohesive and adhesive they are going to use in the fluid mechanics. So cohesive force andre molecular attraction force between the same fluids. So adhesive andre liquid to the solid boundary. So ಈಗ cohesive property ಅಂತಂದ್ರೆ the property of the molding sand by virtue of which sand grain particle interact and attract each other. ಒಂದು ಸ್ಯಾಂಡ್ ಪಾರ್ಟಿಕಲ್ ಇಂದ ಇನ್ನೊಂದು ಸ್ಯಾಂಡ್ ಪಾರ್ಟಿಕಲ್ ಗೆ ಎಷ್ಟು ಅಟ್ರಾಕ್ಷನ್ ಫೋರ್ಸ್ ಇರುತ್ತಲ್ಲ ಅದನ್ನ ಕೋಸಿವ್ನೆಸ್ ಅಂತ ಹೇಳ್ತೀವಿ. ದಟ್ ಈಸ್ ದ ಥಿಂಗ್ಸ್. ಯು ಶುಡ್ ಹ್ಯಾವ್ ಆ ಕೋಸಿವ್ನೆಸ್ ಜಾಸ್ತಿ ಆದಷ್ಟು ಏನಾಗುತ್ತೆ, ಕೋಸಿವ್ನೆಸ್ ಫೋರ್ಸ್ ಆಫ್ ದಿ ಸ್ಯಾಂಡ್ ಪಾರ್ಟಿಕಲ್ ಜಾಸ್ತಿ ಇದ್ದಷ್ಟು ಏನಾಗುತ್ತೆ, ಏನಾಗುತ್ತಪ್ಪ? ಹಲೋ ಹಲೋ ಕೋಸಿವ್ನೆಸ್ ಪ್ರಾಪರ್ಟಿ ಜಾಸ್ತಿ ಇದ್ದಷ್ಟು ಏನಾಗುತ್ತೆ?
The sand won't stick.
Yes, it will. So ಏನಾಗುತ್ತೆ, ಸ್ಟ್ರೆಂತ್ ಆಫ್ ದಿ ಸ್ಯಾಂಡ್ ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಗುತ್ತೆ, ಕಂಪ್ರೆಸಿವ್ ಸ್ಟ್ರೆಂತ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ದಟ್ ಇಸ್ ದ ಥಿಂಗ್. ಅಂಡ್ ಫೈನಲಿ ದ ಥರ್ಮಲ್ ಸ್ಟೆಬಿಲಿಟಿ. So thermal stability is the heat from the casting causes rapid expansion of the sand surface at the mold metal interface. The mold surface may then crack, buckle or flake off unless the molding sand is relatively stable dimensionally under rapid heating. See, thermal stability ಅಂತಂದ್ರೆ, so it is exposed to the high temperature alwa molding box alla, because mold now we are going to pour the molten metal. So aವಾಗ ಏನಾಗುತ್ತೆ, so because of the heating also it going to be deformation take place. So the same thing in the casting process ಏನಾಗುತ್ತೆ, ಸೊ ಇಲ್ಲಿ ಕೂಡ ಅದೇ ತರ ಆಗುತ್ತೆ. ಸೊ ಆ ಹೀಟ್ ಇಂದ ಏನಾಗುತ್ತೆ, ಎಕ್ಸ್ಪಾನ್ಷನ್ ಆಗೋ ಚಾನ್ಸಸ್ ಇರುತ್ತೆ, ಮೋಲ್ಡಿಂಗ್ ಬಾಕ್ಸ್ ಎಕ್ಸ್ಪ್ಯಾಂಡ್ ಆಗೋ ಚಾನ್ಸಸ್ ಇರುತ್ತೆ. ಸೊ ಅದು ಎಕ್ಸ್ಪ್ಯಾಂಡ್ ಆದಾಗ ಏನಾಗುತ್ತೆ, ಕ್ರ್ಯಾಕ್ ಪ್ರೊಡ್ಯೂಸ್ ಆಗ್ಬೋದು, ಬಕಲಿಂಗ್ ಆಗ್ಬೋದು, ಪ್ರೊಡ್ಯೂಸ್ ಆಗ್ಬೋದು, ಡಿಫೆಕ್ಟ್ ಕ್ರಿಯೇಟ್ ಆಗ್ಬಿಡುತ್ತೆ. ಅದಕ್ಕೆ ಈವನ್ ಇಟ್ ಹೈ ಟೆಂಪರೇಚರ್ ಇಟ್ ಶುಡ್ ಬಿ ಏಬಲ್ ಟು ಮೇಂಟೈನ್ ದ ಡೈಮೆನ್ಷನ್ ಆರ್ ಸೇಮ್ ಶೇಪ್. ಸೊ ದಟ್ you should have that property resist that thermal temperature na resist ಮಾಡಂತ ಪ್ರಾಪರ್ಟಿ ಏನ್ ಮಾಡ್ತಾರೆ, it should be thermal stable property ಅಂತ ಹೇಳ್ತೀವಿ. It will be stable in nature even it exposed to the higher temperature. So these are the minimum that is the properties the any molding sand is required. One is thermal property, coziness, adhesiveness, refractiveness, permeability, flowability, dry strength and breeze strength. I think it's enough for today. We'll stop it here. It's already time for me to move from the college. Still I'm dependent.